Today we'll be going over the final Unit 7 assessment review. This is going to prep you for your assessment coming up. The tools that are going to help you today would be this exponent rules poster, which can be found in the mid-Unit 7 review. This is the poster that you use for the first assessment for Unit 7, halfway through Unit 7. And then this poster is what is going to be provided for you for the end of Unit 7, Operations and Scientific Notation poster. And then lastly, if you just go to desmos.com/scientific for a calculator, these are the tools that are going to be very helpful on the assessment. Looking at question number 1. Convert the following number into scientific notation by completing the statement below. 452 million is equal to blank times 10 to the blank. So we have to fill in our coefficient and our exponent. So when we're looking at our number, we don't see a decimal. These are commas. Our decimal is found at the end. And if we remember, our coefficient in front has to be between the numbers 1 and 10. So we need to move our decimal all the way between the 4 and the 5. So our number is going to look like 4.52, and I'm going to drop all the zeros behind it. So I included all the non-zeros and dropped all the zeros behind it. So now what I'm going to do for blank 2, I'm going to fill in my exponent, which I'm going to count how many place values did I move to get until I get to the 4, between the 4 and the 5. So I moved it 3, 6, 7, 8 places. So it's going to be the 8th place. So our final answer is 4.52 times 10 to the 8th. Number 2, convert the following number into scientific notation by completing the statement below. This number is a small number. The reason why we know it's a small number is because 0 is our coefficient. So I know our exponent will be a negative number. So I'm going to put a negative in right away so I don't forget that. So first things first, I'm going to look at my coefficient. So that means I need to move my decimal to between the 6 and the 8, because if I put it at after the 8, it'd be 68. 68 is too big. Our coefficient can be only between 1 and 10. So it has to be between the 6 and the 8. So I'm going to put my number 6.83. I'm going to drop all the zeros in front of it. Now I'm going to drop down to my exponent. I already have my negative sign, and we moved it 1, 2, 3, 4 place values, so it's going to be negative 4. So our final answer is 6.83 times 10 to the negative 4th. Number 3, completing the following statement by converting the number into standard form. So now we're given the scientific notation. Now we need to put it into standard notation or standard form. So it's 4.23 times 10 to the 5th. So what we need to pay attention to is this 5, and that's positive, so that means our number is going to be getting larger. That means I'm moving my decimal 5 places to the right. So I'm going to move it 1, 2, and then I have 3 more place values to move it. So I'm going to add 3 zeros at the end. So our answer is going to be 4, 2, 3, 1, 2, 3 zeros. So we moved it a total of 1, 2, 3, 4, 5. And if you want to put commas in, our answer is 423,000. Question 4. This one's going to be a negative exponent, so our number is going to get smaller. So we're moving our decimal to the left 4 place value because our answer has a negative exponent and has a negative 4. So I want to move it 1, and then I have 3 more place values because 3 plus 1 is 4. So I want to move it 1, 2, 3, 4. So I'm going to put 0.00071. Make sure you include the 1. So our decimal was between the 7 and the 1. Let's just check our answers. And we're going to move it 4 places to the left. 1, 2, 3, 4. And I put a 0 in front. We have it correct. Number 5, complete the following statements with greater than, less than, or equal. So we have 3.67 times 10 to the 8th equals 3.67 times 10 to the 6th. So what we need to do first is look at our, let's look at our poster here. It is... let's see, that poster's not going to help us. So how we are going to get through this is we are going to look at our exponents first. We have the same exact coefficient, 3.67. But let's look at our exponent. Our exponent is going to tell us how many place values we need to move. We're moving to 8 place values to the right. This one we're only moving 6 to the right. So they're saying 3.67 times 10 to the 8th is going to be greater than, so that's going to be A, greater than 3.67 times 10 to the 6th. Next one, 6 times 10 to the 5th is greater than, less than, or equal to 6.1 times 10 to the 5th. Okay, we look at our exponents, they're the same. Then we look at our coefficients. We have a 6 and a 6.1. Which one's bigger? 6.1. It's only 1/10 bigger, but that's enough. So 6 times 10 to the 5th is less than, so that's going to be B. 6.1 times 10 to the 5th. All right, number 3. 7.3 times 10 to the negative 5th is less than, equal, or greater than 0.000073. So that tells us, let's put this number in scientific notation. It's going to be 7.3. We're going to move our decimal 1, 2, 3, 4, 5, 6. So we'd have a negative 6. So it'd be 7.3 times 10 to the negative 6. Which one's bigger? Which one's closest to 0 in this case? Because they both be negative numbers. This negative 5 is closer to 0, so that one's bigger. So 7.3 is greater than 7.3 times 10 to the negative 5th is greater than 0.000073. So make sure you convert these into either both scientific notation or both into standard notation. I made them both into scientific notation. All right, so this one we have 9,700,000,000 is greater than, less than, or equal to 9.7 times 10 to the 9th. So I want to make this 9,700,000,000 into scientific notation. My decimal has to fall between the 9 and the 7, so it's going to be 9.7. So that's going to match up. Now let's count how many decimal places we move. 3, 6, 9. So it'd be 9.7 times 10 to the 9th. That would be equal. So equal would be C. And our last one, we have 7.3 times 10 to the negative 3rd, 6.2 times 10 to the negative 2nd. Just by looking at the number of place values we have to move, we only move 2 places to the left, 1, 2, so it's going to be a 0 in front here. This one's going to tell us we have to move 3 places, so it's going to be 1, 2, 3, so we're going to have 2 zeros in front. So that should tell us 6.2 times 10 to the negative 2nd is bigger. So in our answer, it's going to be 7.3 times 10 to the negative 3rd is less than, so that's B, 6.2 times 10 to the negative 2nd. All right. Number 6. Arrange the following numbers in order from least to greatest. So they're all in scientific notation. And the first thing we need to do is, and they're all in proper form, we can look at our smallest exponent. We have a 9, a 7, a 8, and a 7. So we have 2 7s. Those are our smallest ones. We look at our smallest number. 5.41 times 10 to the 7th would be our smallest number. And that one we're going from least to greatest. So that one's in the right spot already. So we're done with that one. Then it would go our 6.3 times 10 to the 7th. That's in the correct order, so we're going to keep that as second. Then we're going to look at our exponents of 9 and 8. 8 is smallest, so it's going to be 8.7 times 10 to the 8th. And lastly, 5 times 10 to the 9th would be our largest number. These are right in order. We didn't have to move anything. All right, number 7. Arrange following in order from least to greatest. So this time we have a mix. We have some in scientific notation and one in standard notation. So what I'm going to first do is I'm going to put these in order. So I want to make this in scientific notation, this last one. So it'd be 5.67 times 10 to the 1, 2, 3, 4, to the negative fourth. So now we're going to look at our smallest number. In this case, this is going to be the negative fourth. Our smallest exponent is going to be our biggest negative, because they're all negative exponents. It's going to be 6.8 times 10 to the negative 6 would be our smallest. Then we have, so this will be set to the 1, 2, 3, 4. 1, 2, 3, 4 to the negative fourth. So negative fifth is the next smallest, so I'm going to move this one up here. These are both to the negative fourth. So this would be 5.4 and this would be 5.6 as our coefficients. Which one's further in the whole? Being they are both negative. This one's further from 0, so that would be our third. And our last one would be 5.4 times 10 to the negative fourth. All right. Question 8 says match the number with the expression written correctly in scientific notation. So the left side's in standard form, right side's scientific notation. Notice there's only 5 on the right, on the left, and there's 1, 2, 3, 4, 5, 6, 7. So 2 of them will not be used. So we have 8,500,000. So how would we write that in scientific notation? Our decimal has to fall between the 8 and 5. So we're going to move it 6 places. So we're going to be 8.5 times 10 to the positive 6. 8.5 times 10 to the positive 6. That's G. Number 2, it's going to be a negative exponent, being it's a tiny number. It's going to be 8.5 again. And we're going to move it at 1, 2, 3, 4, 5. So it'd be 8.5 times 10 to the negative fifth. And that'd be letter D. 85,000. Our decimal is going to fall between the 8 and the 5. It's going to be a positive exponent, being it's a large number. And we're moving it 4 places. So it'd be 8.5 times 10 to the 4th, positive 4th. So that'd be A. 0.000085. So it's going to be, the decimal is going to move between the 8 and the 5. It's going to be a negative exponent, being it's a tiny number. So we're moving it 1, 2, 3, 4, 5, 6 places. So it would be 8.5 times 10 to the negative 6. So it would be letter E. And our last one, 850,000. Our decimal is it's a large number, so it's going to be a positive exponent. Our decimal is going to fall between the 8 and the 5, and we're moving at 3, 4, 5 place values. It's going to be 8.5 times 10 to the 5th power. So it'd be letter F. Number 9, find the product and then fill in the blanks. So in this case, we are looking at we have a problem here, 2.4 times 10 to the 5th, all multiplied by 3 times 10 to the 3rd. You might want to review this worksheet, operations in scientific notation. Multiplying, so the first thing we need to do is multiply our coefficients. Then we are going to add our exponents. And then if we're going to look at our answer to make sure it's correctly in scientific notation. So multiply our coefficients and then add our exponents. So we're going to multiply 3 times 2.4. So if you want to do that in Desmos, 3 times 2.4 is 7.2. So we're going to write 7.2. Oops. Then we're going to add our exponents. 5 plus 3 is 8. So our blank down here would be 8. So 7.2 times 10 to the 8th is in proper form, so we don't need to do anything else. Another multiplication problem. So we're going to multiply 4 times 3.26. That'll be the very first thing. 4 times 3.26. So go back to Desmos. 4 times 3.26 is 13.04. Sound right. 13.04. Then we're going to add our exponents. We have -5 plus 3. If you don't want to mess with opposites, so just put it in your decimals. -5 plus 3. So -5 times, plus 3 would be -2. So our exponent would be -2. So now we got to see to make sure that this is in correct scientific notation. It is not. 13 is too big. We have to move our decimal one place to the left. If you remember Lars, put it right here so you can see we're moving one place. Let's get rid of this decimal here. We move left, so we have to add 1. So we're going to go -2 plus 1. -2 plus 1 is -1. And when we move our decimal one place over, it's going to be 1.304. So that would be our final answer, 1.304 times 10 to the -1st. Number 11, choose all the expressions that are equal to 8 times 10 to the 6th. So we have our decimal at our number is 800,000, and we need to make this into scientific notation. So it'd be 8. I'm going to move my decimal between the 8 and 0. So I'm moving at 3, 4, 5. So 8 times 10 to the 5th. So that one doesn't work out. 80 to the 6th power. So that means if I would move this, if I put this in correct form, if you even go like this, another way to do this, 8 with 6 zeros behind it, and this would be 80. Here, let's go. I'll show you. 80 to the 6th power. 80, and then I'm going to put to the a to b here. That means my exponent to the 6th power. So that would not be the same. So we don't select that one. 80 times 10 to the 5th. I want to put this in proper form. I want to move my decimal. Right now our decimal is after the 0 in 80. So I want to move it 1 to the left. In Lars, L and A go together. Since I moved it left, I want to add 1. So it would be 8.0 times 10 to the 6th because we have to add 1 to it. So that one works. This one we're going to multiply our exponents. 4 times 2 is 8. That works out. And we're going to add our exponents. 8 plus -2 is 6. So yes, this one works. And then dividing, we haven't did a dividing one yet. On here, let's just take a look. When we divide, we need to divide our coefficients. Then we're going to subtract our exponents. And then we're going to see if we need to fix our answer to make sure it's in proper scientific notation. So we're going to divide and then subtract our exponents. 2.4 divided by 3. So let's do that. 2.4 divided by 3 is 0.8. So 0.8. And then we have to subtract our exponents. 9 minus 2 is 7, so 10 to the 7. So right now we have 0.8. I'll change that, 0.8, so you can see what I'm doing here, 0.8. And we had 10 to the 7th. So let's look at our answer here. This is not going to be in scientific notation, so I had to move our answer to the right. I'm sorry, decimal to the right. In Lars, if I'm moving right, I need to subtract my exponent by 1, being that because I'm moving it 1. So when we move it, it's going to be 8, and we need to subtract 1 from 7 is 6. So this one would work. So our answer is C, D, and E. Find the quotient, then fill in the blanks. So if remember, we're going to divide, then subtract. So 10.92 divided by 2.1. 10.92 divided by 2.1. So we have 5.2. 5.2. and then we have to subtract our exponents. 15 minus a negative 3. Just type it right in your calculator. 15 minus a negative 3. Notice I have minus a negative. It's positive 18. So our exponent would be 18. Our last step to make sure this is in correct scientific notation, it is. Our coefficient is between 1 and 10, so it all works out. And our exponent has to be a positive number. I'm sorry, has to be a whole number. It can be positive or negative, but it has to be a whole number. Next one's another division problem. So we're going to have 2.16 divided by 3.6. 2.16 divided by 3.6. See if I did that right. 3.6, yep. So we have 0.6 for our answer. So I'm going to get rid of this. 0.6. I can do it right here, 0.6. Then we have to subtract our exponents. Negative 4 minus 3. Negative 4 minus 3 is negative 7. So we have negative 7. Last thing to make sure that this is in correct form. This coefficient's too small. I need to move my decimal 1 to the right. So when I move it 1 to the right in LARS, L-A-R-S, we need to subtract 1. So it's going to be negative 7 minus 1. It'll be a total of negative 8. So now our answer would be 6 times 10 to the negative 8th. And now this is in correct form. Number 14, we're subtracting. So let's take a look at our rules. Subtracting is here. First, if your numbers have different powers of 10, rewrite one of the numbers so they have the same power of 10. In this case, we have the same power of 10. So we need to subtract the coefficients and keep the same power, and then check to see if we need to fix our final answer to be in correct scientific notation. So being that our exponents are both negative 7, we're just going to subtract our two coefficients. So 8.86 minus 3.21. 8.86 minus 3, is it 0.21? 0.21. And we get 5.65. 5.65, and then our answer, what it said, we just keep our exponent of negative 7. We make sure that this is in correct form, scientific notation, and it is. 15, find the sum, that means add. So in this case, we're going to have the same exact rules. If we have the same exact exponent, we're just going to add our coefficients. 2.8 plus 9.8. 2.8 plus 9.8. And we get 12.6. So I'm going to put 12.6. And we keep our exponent the same, 4. And I'm just going to prove to you where I'm getting this when we add. First, if the numbers have different powers of 10, rewrite one of the numbers so they have the same power of 10. We already have the same power of 10. Then it says add the coefficients and keep the same power. And that's what we did. Last step is to making sure that it's in the correct scientific notation. Let's take a look. We have a problem. This 12 is too big. So we need to move our decimal one place to the left. So it's going to be 1.26. And when we move it 1 to the left in LARS, we have to add 1. So 4 plus 1 is 5. So now we have 1.26 times 10 to the 5th. That is in the correct form. Number 16. This one we are adding again. We have to make sure they're in the same exponent. In this case, they're not. So what I'm going to do is I'm going to make this number, 2.2 times 10 to the 4th, I want to change this to the 5th. So if I did that, if I want to add an exponent, I need to move my decimal one place to the left. So this is what I'm going to be writing in. 5.08 stays the same. I'm adding, so plus, and I want to move my decimal one place to the left because I added. So it's going to be 0.08. 0.22. So I'm going to take that, I'm going to copy it, and I'll put it in Desmos to paste it, and we get 5.3. So I'm going to put 5.3, and we have 10 to the 5th. That could stay the same, and we look to see if this is in the correct form, and it is. And last question of our review, find the difference. So we're going to subtract. First thing we look for is that they have the same exponent, and they don't. So I'm going to move this one. I need to add one, so in Lars, if I need to add one, I need to move my decimal to the left. So I'm going to just get rid of this. I'm going to put 8.9 minus, and I move my decimal one place to the left, so it's going to be 0.37. So what I'm going to do is I'm going to copy that. I'm going to paste it in decimals. Clear this. Paste it. And we get 8.53. 8.53. And we're going to keep our exponent the same. I converted this to an 8, so it becomes 8. We look to see if we're in correct form, and we are. If you have any specific questions, please let your teacher know. Have a good day.